In this video we're going to take a look at question 27 from chapter 3. This question has a selection of topics within it. There is a data file on Moodle which accompanies this question. Please take the time to download this and do attempt the question yourself. I have already downloaded the data. It should come like this. You will need to copy and paste it into a new workbook to ensure that you are able to save the document later. Part A requires us to calculate some measures of central tendency. We are asked for the mean and the median. The mean is probably the easier of the two to calculate. We can use Excel's functionality here, equals average, open bracket, select the range and only the data, close bracket, enter. Our mean is 3.99. Next we come to the median. Before we calculate the median, it is necessary to sort the data from smallest to largest. When you're given a sort warning, select Expand the selection and click Sort. This sorts from smallest at the top to highest at the bottom. We need to do this because to calculate the median, we first must calculate the position of the observation which is halfway through our 20 observations. Here, n is 20. So our median should lie at the 10th observation. But wait, there's a catch. Because we have an even number of observations, we do need to be careful. The median, that is the exact halfway point, lies halfway between the 10th and the 11th observation. The 10th observation is 4.17. The 11th observation is 4.2. Let us find the exact halfway point. We add our two observations together and we may divide by 2. Our mean and median are not the same. Our median is 4.185. Okay, that's no problem. B requires us to calculate the first quartile and the third quartile. It is possible to calculate the second quartile, but the second quartile is the exact halfway point, which is also known as the median. So we're going to apply a very similar method to calculate our quartiles. First, we must calculate the position of the first quartile. It's 1/4 of the way through our 20 observations. So it should lie at position number 5. The observation at the 5th position is 4. Our first quartile is 4. Now we can apply the same logic to calculate our third quartile. It's 3/4 of the way through our 20 observations. So it should be at position 15. 11, 12, 13, 14, 15. At position 15, we find 4.5. Our third quartile is 4.5. Now we know that the central 10 observations, or the central 50% of our data, lies between 4 and 4.5. Question C asks us for the standard deviation of our data set. It is possible to calculate standard deviation manually. However, this takes quite a while, has a good number of steps, and there's a good chance that you'll make a silly mistake somewhere along the line. It's far easier to use the inbuilt functionality. Here, the function is stdev, stdev. I open bracket, select the data and only the data, close the bracket and press enter. Our standard deviation is 0.81. Now it would be wise to take a look at the questions again. Part D asks us to calculate some z-scores associated with two particular companies. To calculate a z-score, we need to know the observation value, we need to know the dataset's mean and the dataset's standard deviation. We've just calculated these, so we can have quite a quiet life. The first company we're interested in is Omni Audio. Let's highlight it so we don't lose it. Our observation value here is 2.32. Now let us calculate the z-score. If you're unsure of the formula, feel free to look it up in the textbook. Our observation, take away the mean, divide through by standard deviation. You'll note I'm using brackets here. This just reduces the number of steps because the brackets tell Microsoft Excel what order of operations it should use. Here we have a negative value. The negative z-score shows us that 2.32 is a little over 2 standard deviations below the mean. The z-score measures the distance between an observation and the mean, and the unit of measurement is standard deviations. Now we do the same again for Alison 1. Their x value is equal to 4.12. So our z-score is going to be, open bracket, 4.12, take away the mean and divide through by the standard deviation. Here our z-score is 0.15. Let's round it to 0.16. This is showing us that 4.12 is 0.16 of a standard deviation above the mean. In this case, the two values are quite close and we can eyeball this. Part E requires us to decide if the dataset contains any outliers. Here we're going to employ a general rule of thumb, which is to say an outlier is any value which is 3 standard deviations higher than the mean or 3 standard deviations or more below the mean. In other words, if we imagine a distribution, anything which is beyond 3 standard deviations is really in the tails of the distribution. Anything in the tails we're going to assume is an outlier. So, what I'm going to do here is I'm going to calculate z-scores for the lowest observation and the highest observation. Because if these observations are not outliers, I know that everything else cannot be an outlier. Okay, let's quickly calculate a z-score for the lowest rating. Here we have negative 2.28, so this is within the central 3 standard deviations. So 2.41 is not an outlier. Now we apply the same logic again to the highest observation. Open bracket, observation value, subtract mean, let's close our brackets, and divide this through by standard deviation. Here, 4.88 is only a little over 1 standard deviation above the mean, so this isn't an outlier either. So, here we may conclude that we do not have any outliers in our data set. This means that every observation is within 3 standard deviations of the mean. If we were to hypothetically assume that we had a bell-shaped curve, that means we can be very confident that the central 3 standard deviations would contain 99.7% of our observations. We're confident that no observation is in that 0.3%, which is in the tails. That's 0.15% in each tail. This should be accompanied by a more detailed solution I've produced, which is available on Moodle. Hopefully between the 2 resources you should be able to solve this question independently. I do encourage you to ensure that you can do this unaided. Thank you very much for your indulgence, and I wish you